Okay, at time t equals 0, the height of the water is 5 feet. I'd write that down. H of 0 is 5. Again, I'm not anticipating, I just read. Use separation of variables. Okay, SASSI is basically, separation of variables in SASSI are the same thing. To find an expression for H in terms of t. The other way I knew that I needed to use SASSI was this idea here on the golden notes, because as I was reading this problem earlier, I had this amount rate table, H, and I notice now that what's happening is they have given me a formula for the rate. This formula for the rate contains the output variable h. The input variable is t. So just like it says in this box, when given a rate, to find the amount, we use the fundamental theorem, except when the formula for the rate includes the output variable. We have to use the SASSI method. This box says the same thing in a slightly different way. So I know it's SASSI. So we'll get to work on that. So I write dH dt is equal to negative 1/10 square root of h, multiply the dt across, and they give 1 point for that. So now I'm looking at the, oh, not yet. Sorry, that's not enough. Got to move the h. Got too excited there. So now I move the h. So I end up with, oh, this is a dt. So I end up with 1 all over root h dh equals negative 1/10 dt. Now my variables are separated. And so now I get the 1 point for separating. Now we're going to take the antiderivative of both sides. This root h is a problem, so that's 1 over h to the 1/2, which means that's the antiderivative of h to the negative 1/2 when I move that to the numerator. The antiderivative of negative 1/10 is just going to be negative 1/10 t. Just like the antiderivative of 10 would be 10t. I still need to find this antiderivative. So that's going to be h to the negative 1/2 plus 1/2. Negative 1/2 plus 1/2 is 1/2. Equals negative 1/10 t plus a constant. So dividing by 1/2 is the same as multiplying by 2. So I end up with 2 root h, because h to the 1/2 is root h, equals negative 1/10 t plus my constant. If I get to here, they're going to give me 1 point for correctly doing the antiderivatives. I went to the next line just to make subsequent work easier, because now I'm going to constantate. So height of the water is 5 when time is 0. So 2 times the square root of 5 is going to equal negative 1/10 multiplied by 0 plus c. So we correctly figured out that c is equal to 2 root 5. That's 1 more point. In some older AP tests, they would often give 2 points for that, but this test they chose 1. Last thing is to get the h alone. So we go back to this equation, and we're going to need some more space, but we're going to take that equation, plug in the c. So copy this over. 2 root h minus 1/10 c. So I have this, 2 root h is equal to negative 1/10 t. 2 root 5 is our value for c, plus 2 root 5. The idea is to isolate the h. The isolate step often takes a lot of work, but in this case it does not, so it's worth continuing, because we're going to get root h is equal to, no need for algebraic simplification. I included that note in the quiz 6 notes today. So divide all that by 2. We're trying to get rid of the square root, which means we square both sides. So last step is simply h equals all of that squared. And they do give one more point for that. That concludes the practice test question 2. Question 2 in this case was worth a total of 9 points. So again, the things you have been practicing are a bit more than what they appear to be giving as far as the test this year. Because I've been giving you part B's that were typically worth 11 points. Hence, took a little more time. So that's good news as well. But for this one, only 9. And I explained that in my notes for quiz 6. So.